Good day, everyone. My name is Fayad. I'm a PhD student at the University of Montréal under the supervision of Sébastien Sauvé in the chemistry department. Today I'll be presenting to you my poster, the online SPE-LC-APCI-MS method for determination of steroid hormones in water. So why are these compounds important here? It's because we know that they have an effect here on wildlife and human reproductive physiology. So these are known impacts of these types of compounds, which are endocrine disruptive compounds. We have the structures here of 8 steroid hormones that we'll be studying today in affluent wastewater. We have the estrogens, and we also have 4 progestogens, so 4 in each family. And we'll be analyzing these by the online SPE method. So here you have the picture of the online SPE method. We have here the injection loop. It's a 10 ml injection loop here. We also have our SPE online cartridges. So the idea is to actually get a volume here from our sampler. So we pick up a volume here directly. We go into the loop here, into the 10 ml loop. We fill this loop. And by back flushing with the LC pump, we're able to bring our wastewater into the SPE cartridge where we concentrate our analytes here. Once that's done, we have our MS pump that will actually do a back flush and pump our analytes out of the SPE cartridges, go towards the analytical column, have separation, and then go towards the detector, which is the triple quad here. Here we're using the Thermo TSU quantum triple quad for the analysis of our compounds. The columns here that we're using are hypercell gold 1.9 micron, 100 times 2.1. We have 2 loading columns in tandem. I will show you why here we're actually using 2 tandem SPE columns. So we're trying to get a higher volume of loading here to lower our emissive detection. So we have 2 hypercell gold AQ columns here, 20 by 2.1 millimeters. So here you have the different MS parameters that we're using. So we have the precursor ions, also the product ions. We're working in positive mode, APCI. And these are the different fragments that we use to quantify and also to confirm the presence of our hormones in this wastewater affluent. So the first thing is we're trying to actually optimize the different parameters of the SPE online. The first thing we looked at is actually the loading volume, because this will be important in actually getting lower limits of detection. So what we did here is we actually injected a fixed concentration, 300 nanograms per liter, and it went from 1 ml to 20 ml injection. And once we saw that the curve was not linear anymore, we had breakthrough. So in our case here, and this has only been allowed because of using the tandem SPE method here, we're actually able to inject 10 ml. And the other interesting thing here is if you look at signal to noise, in this case, signal to noise keeps rising here with rising volume. So this shows us that there actually is a difference between the peak height of our compounds and the noise here. So that's very interesting also, so we have to look at it also. The other parameter that's very important here, especially for SPE Online, is the speed at which we're going to be loading our SPE cartridges. So as you can see here in figure 3, we're actually using 500 to 4,000 microliters a minute. And you can see with the tandem SPE method, here our concentrations, this is absolute area here on the y-axis. It stays constant throughout the use of different speeds here. That means that we actually load at 3,500 microliters a minute with no issues of breakthrough. We also did the normal validation parameters. What we did here is we also validate the different matrix effect by using calibration curves, by actually dividing the slopes here, we're able to see. So we're dividing slopes for hormones tested in HPLC water and also in wastewater affluent. So these 2 here, the red is in the wastewater, the green is in the clean water, in the cleaner water actually, in the HPLC water. And by dividing those slopes here, we have matrix effect. So here you have the summary of the matrix effect here. So anything over 100 is signal enhancement. Anything under 100 here is matrix suppression. So in general, we have some suppression, and we have a few compounds here, especially for the estrogens, where we have some kind of enhancement, but the bar errors are also pretty high. So here we have the traditional method validation also here. So we did all the methods. We have all the calibration curve, R squared, the different QCs that we use, and you see the RSDs are very good here if you look at these later on. And we have the LODs here I want you to look at also here. The LODs here in affluent, so affluent wastewater, is between 31 and 102 nanograms per liter, whereas in cleaner water, so HPLC type water, we have between 11 and 32 nanograms per liter. We also tested recovery. So recovery is important. Why is it important? Because if we have more compounds going into the system, more mass, we can lower limits of detection. So we're trying to get 100% recovery if we can. In figure 6 here, which you can see is the recovery values, tested 2 different methods here and also 2 different concentrations. Globally, what happens here is that for recoveries between 65 and 100 for different compounds, with the estrogens having a bit less recovery than the progesterone, which is expected because of they're slightly more polar than the other compounds there that we're studying. And also here what I'd like to show you is the chromatogram of our compounds. So here the idea is to show you how we're able to get our peaks actually separated from the matrix effect. So here in the back you have superimposed chromatograms of our blank, which is not, no gray areas here. And we have our peaks that are in gray here. And just to show you the difference here, and now we're able to move with our chromatography, is actually to be able to move our peaks from the matrix, allowing for less interferences and less suppression for our compounds here. So we're happy with that here. So in conclusion, I would like to say we actually developed a fast and sensitive method for the determination of 8 steroid hormones in a wastewater and different water matrices if needed. We have very good values for the validation, good RSDs, good reproducibility. We're able to inject from 1 to 10 ml. And also what's interesting here, the time of the method here, we have about 10 minutes per sample. So we're very happy with that time. And bear in mind that the interesting thing here is that we're higher throughput than the offline SPE method. And also here we're able to reuse these cartridges to about, in our case, about 250 times. So this is reusable. It's less labor intensive also. So on that note, I'd like to thank you very much for your time. If you need more information, please go to thermoscientific.com/ASMS. Thank you all.